My advisor, the late Bill Larson, the late Bill Larson, gave me some advice. He gave me advice quite a bit at the time, but one of those, he says, if you're ever the last speaker of the day, he says, if you do have any audience left, you have two options. He says, one, he says, you give the best damn talk they've ever heard. Well, that's probably not going to happen. Or the other is, he says, you just skip a bunch of slides that you normally would have given earlier in the day. So you know which way we're going to go. So if this looks like an animation that's not working really well, you know why. Okay. Okay, so you get to give credit where credit is due. I talk about it, but these guys are the ones who really do the work. You know, we don't have any erosion in the U.S., so I took these pictures in China and the Ukraine. Not really. You know, even Stevie Wonder can tell what's going on. It's reality. You know, and I'm listening to some of the presentations given on aquifer depletion. This is a water conference. And I start thinking, you know, when the water is gone, as it is being lost in some of the western areas, farmers can still farm, but they can't produce very well. You know, when our topsoil is gone, we can still farm, but we're not going to produce very well, and we're not going to be very resilient. So I'm trying to capture some of the messages you've been using that have worked with farmers to help them conserve water, that they're willing to work in the conservation area, because some of those tools, methods may work as well for us. Animation? Okay. So I was serious. You know, there's cold one waiting for me too. So how do you make an estimate of soil erosion over a large geographical area? We've covered Iowa, and now we're working in Nebraska, and you'll see some information here about Nebraska. Minnesota, we have requests for expansion. So how do you do this? You know, as you move from one location to the other, the hill slope's different, the hill length is different, what's being done in the field is different, soils are different, you know, rainfall varies tremendously, and this is real time. So how do we do that? Just a couple thought slides. At this time of day, the mind is pretty numb, so we're not going to push it very hard. The first thing you have to have is a model that has been vetted in the literature and that is process-based, because we want to work real time. We're using a wet soil erosion model. So he said the big question is, how do you give it the inputs necessary to make it work correctly? Well, over large space, the only way you can possibly do that is by remote sensing. Again, those remote sensed inputs have to be georeferenced. You have there's selected georeference layers that you use to feed the model. We're going to give you some of those to illustrate what we're doing. We're using NextRad radar to give us our rainfall estimate. For every square kilometer, we have a rainfall estimate every 2 minutes. And those rainfall estimates are georeferenced. We use LiDAR to get slope length and steepness. We use electronic soils database, GCircle, to give us our georeferenced soils. Soils influence soil erosion rates. We have the boundaries of everyone in Iowa, 400 and some odd thousand fields. Within those boundaries, we use remote sensing, satellite imagery, other electronic databases to get the crops that are grown in those fields, and the tillage, because those are inputs necessary for the wet model. And from that, we get a crop growth, which is just used for soil water purposes, and water runoff, and soil erosion estimates. Okay, the next thought slide. We can't model every field. We can't make an estimate on every field. We don't have the computer power. And the data intensity would be incredibly different. It'd be intense. So we subdivide the state into HUC 12 watersheds. We divide the region. You know, I'm just giving you the Iowa here because we're more familiar with that. Within Iowa, there are 1,600 and some odd HUC 12 watersheds, but they're on average about the size of the township. Within each HUC 12, Would you trust a soil erosion estimate for that HUC 12 if we gave you the estimate off of one hill slope? And no, it ain't gonna happen. So we subdivide those HUC 12, each HUC 12, into smaller watersheds. We do what's called a stratified random sampling. We subdivide each HUC 12 into smaller sub-watersheds and then randomly select one hill slope within that sub-watershed. Within each HUC 12, we have about 120 to 160 sub-watersheds. So we have about that same number, 120 to 160 hill slopes that we use to give us our HUC 12 soil erosion rate for each day. Okay? Animation. You don't want to go there. They're either, well, let's start here. You know, I don't see a clock or anything. It's somebody tell me to stop. I was giving a talk one time and that's going on and on and on and on. Even I knew I was taking up lots of time. I said, has somebody got a watch? I really don't know what time it is. The guy in the front row says, you don't need a watch, you need a calendar. So, we'll get that. Okay, so we're going to show you what the model is seeing, or what it's seeing and how it's doing what it's doing. We're going to take a HUC 12. That's the black line outlines the HUC 12. We're going to take a section of it and expand it. Within that expanded area, you see other lines, in this case black. Those delineate those subwatersheds that I mentioned that we form, that we identify. And we're going to expand that further. Now we've changed the HUC 12 or the subwatershed boundary colors to blue. Within each one of those, you see a line that is part yellow and part black. Those are the randomly selected hill slopes, flow paths, that we use to get a soil erosion estimate for that one subwatershed. Keep in mind the color of the yellow and black. We're estimating only sheet and rill erosion. We model to the part of that yellow-black line to where we think ephemeral gully erosion starts to dominate. So now I'll show you some map of the erosion estimates that we have. Those are only sheet and rill numbers. Those do not include soil that's lost, like what you saw in those original pictures. John Laughlin says, he developed WEP, he says if you can see it from the road, we're probably not estimating that loss. Don't need that, don't need that. Okay, this is what is being estimated. That's that yellow and black. We're estimating the amount of soil that's moving along the hill slope past that yellow arrow head. Then we stop. Now I've got one for you. We have increased the amount of no-till in the Midwest because of what technology? What is the biggie? Hello. Herbicide. Roundup technology. GMO technology. Okay, so when you look at this map and see how we're making soil erosion estimates, that technology works really well for our estimation because we have no-till up on the slopes. How many grasses do we have that are herbicide tolerant that would be in the grass waterways? If it was, it would be a weed. We have lost numerous grass waterways, which has accelerated our ephemeral gully losses, but those are not being considered at this point in time. So what are we observing? We see a couple things here. Those are different years. Upper left-hand corner is 2008, 2009, upper right, 2012, bottom lower, and 2010, which was a pretty wet year. You can see the differences between years. Those are color-coded, the ramps range of colors. The darkest black is over 60 tons estimated in the year. We summed the daily numbers up for each one of those years, so those are yearly totals. You see the spatial distribution across the state and the difference between years, attributed dominantly to changes in precipitation. I mean, we've got some changes in management, but not enough to create those kind of differences. So we're sensitive to both space and time. If you take the entire time period over which the modeling has been done, or the estimations have been done, well, this is not the entire, but 2008 through 2016, we are estimating for the state of Iowa that we are losing about 5.1 tons per acre per year of soil from the hill slopes. We are losing on average across the state, even though you see in some areas we're averaging well over 20, some over 40 in the Loess Hills in western Iowa. Average statewide, we're 5.1. People say, well, how do you know this is even close? How do you know your numbers are even close? Well, I'll show you in a slide a little bit later. The NRI, the Natural Resources Inventory, makes estimates statewide periodically every 5 years and then publishes those. The NRI estimate for this period is about 5.8. So we have two numbers done completely different that come up pretty close to the same. Does that mean we're right? Absolutely not. Could be a comedy of errors, but in doing research, when you do things different and come up with the same answer, it's evidence that we're at least playing in the same game. We're in the ballpark. So one of the uses that we have is we can isolate periods of particularly heavy precipitation. This is a 4-month period from April 2008 to June of 2008. Precipitation estimates, spatial precipitation estimates, are in the upper left-hand corner. You can see in some areas, northeast Iowa, we had rainfall of over 20-some inches in that 3-month period. The runoff is in the upper right. And in some of those areas, we've lost, our estimated loss, 8 to 10 inches. 8 to 10 inches of runoff. And then our soil loss. Kind of wicked. What's our soil renewal rates? Any idea what our topsoil or our soil profile renews, what the rate is? One. That's a good answer, but for a different question. It's the best science suggests it's somewhere between about 0.25 and maybe 0.6 tons per acre per year. What is T? What is the tolerable soil erosion rate that NRCS uses? 5. It's 5 for most soils. So what's considered tolerable, the soil loss rate that we use to allow farmers to capture subsidies and financial support for a variety of programs, is about 10 times faster than what our soil renewal rate is. That's not a push on NRCS, but that's just the fact of life that we're working with at this point in time. So that's just a graph of what the NRI estimate is through time, 1982 through 2012. That's the blue lines or blue symbols. And the orange is the Daily Erosion Project estimate for statewide during the period 2008 through 2016. So again, we're in basically the same ballpark as they are. We give the spatial resolution and the temporal resolution a little bit different. Someone asked me, they said, well, why daily? What's the benefit of that versus an annual estimate? If we're going to design conservation practices that keep soil in place, it makes a big difference if you lose 5 tons of soil, 300 pounds a day, or if we lose 5 tons of soil in one rainfall event. That's why we have a rainfall period, a temporal resolution of 2 minutes. Storms rise in intensity very fast, and the majority, strong majority of your soil loss comes from those very peak moments. So the temporal resolution in terms of what we do in the future is important. So and other people ask, so why? Who's interested in this? What do you do with this? Well, it allows us to focus resources. Where we know damage has occurred, it allows us to focus what limited resources we have for correction measurements, water impairment areas. What is the source of water impairment, water runoff, particularly phosphorus and sediment? Scenario evaluation. We've done a variety of studies where you take out one layer, say the climate layer, and retain everything else from the time period we've done and add a new climate regime and see what happens. What happens if we take out our tillage profile and move the whole state to no-till? What happens to our soil loss? I'll tell you, if we put everything, all of our row crops in no-till, our average soil loss drops to between 0.5 and 1 ton per acre per year. It's initial setup for, you can read that as well as I can. You don't need to go further on that. So where are we going? We were in Iowa only, and we've obtained contracts, requests to expand. Now we are across most of Minnesota, or will be. This is a dated map. We've got some actual functioning going on now in Nebraska, southeast Nebraska. It's up on the web. We're working with Nebraska. Roughly, we'll have that on the web in a couple of years. The eastern 2/3 of Nebraska, Missouri, Kansas, active up on the web in areas of Kansas. So we're growing, and I'm just hoping it's a healthy growth rather than something like a benign tumor. But the interest is there. And